just like.
Before class, we should like. I said 43. You said. I changed it immediately.
Okay.
46 is fine.
So, working more with the graphs. Yesterday I gave you that typed up sheet. Like if you have an F prime graph and you're asked for relative min, you could look at the text and it'll tell you like what to look for. We're going to do that same thing, but in a graph form, and we're going to go through it together. I feel like that's probably more valuable than just giving you the sheet. So, for example, the f of x row is pretty easy. This is saying if f of x is increasing, what does f of x look like? What does f prime of x look like? What does f double prime of x look like? What?
Good job.
I thought you were excited about that.
Yes. They got yes. Yes.
Assholes. I was like, wow, they're really happy I made this.
It is a.
It's just
I'm gonna frame it.
whatever. So if f of x is increasing, what does f of x look like? I mean, it's going up, it's got a positive slope. It's pretty apparent to most of the f of x row. I don't think it's too big a deal. But f prime and f double prime is where I really want to spend more time. So if f of x is decreasing, what does f of x look like? Well, it would be pointing down. And have a negative slope.
Sorry.
What's up?
Oh, I just want. Oh. Wow. I don't even know how that got there.
What is that?
He's mine. Yeah. Justin had it, and then it was gone.
It kind of fits
carrying it
though.
around for a while. There you go. Thank you so much. It's super warm. No.
Relative max. If f of x has a relative max, f of x looks like, that's like the top of a hill. A relative min on f of x would look like the bottom of a hill. Concave up on the original graph either looks like this or like this. Or you get that like U shape if you want to combine them. Concave down, the separate pieces look like that, or if you combine them. N shape, and then a point of inflection would be where we switch from concave up to concave down. So that's just sketching out like what those things mean on the original graph. I think that's pretty straightforward. Those all fair enough. So then the difficult part for most people is, okay, now what if we have a derivative graph? We've talked about all this, but I think this will help like kind of summarize it. Maybe if f of x is increasing, what do we know then about f prime of x? So we can say it's positive. If you're looking at a graph, what does that mean? Above axis. I don't know if I want to graph that. Can I just say like positive above axis? It's up to you. It's your sheet paper. If you want to put like up there, circle the above axis where I guess. So decreasing is the opposite, right? If f of x is decreasing, f prime of x is negative. Below axis, if you want to draw a little axis, circle below. In case you forget what below means, I don't know. So what would a relative max look like on a derivative graph? Are you doing stats?
Yeah.
Do you do English in my stats class? Do you do stats in my calc class? You got this?
Yeah, I'm writing down.
When do English class. It's like a big cycle.
It's like a whole thing. I'm listening.
I know you're gonna take care of it too, but I'm just like, weird.
Yeah.
The way you, or whatever. You do you. So what does a relative max look like on a derivative graph? It crosses the axis is true, but we care about which direction. So it's got to cross high to low or low to high. It's got to cross high to low because when it's high, when it's above, the original graph is increasing, right? When it's below, the original graph is decreasing. So then we get this up down. That's a relative max. So this crosses x-axis above to below. So it's got to be in that direction to be a relative max. It's got to be both sides. That's like my example of crossing from above to below. So that relative min's the opposite. So we cross the x-axis from below to above. So there's my little example at that spot on f prime, there would be a relative min on f of x. Questions yet? It's making sense what I'm trying to go through here. Concave up. So if I'm looking at the derivative graph, and I want to know about the concavity of the original graph, what am I looking for there? This is how most people start to struggle. This is probably the hardest one for almost everybody, at least three. Concave up means what is true about the second derivative. So you're jumping ahead, but yeah. So if I were to say what's true about the second derivative when f of x is concave up, do we agree that that's positive? The second derivative is positive if the original is concave up. Well, if the second derivative is positive, doesn't the derivative of the first derivative have to be positive? Because that's the second derivative, right? So the derivative, are we there? Are we with me there? The derivative of the first derivative has to be positive. Isn't the derivative of the first derivative the same as the slope of the first derivative? So we want a positive slope on the first derivative, or we want it to be increasing. Going up. And then concave down is the opposite. We want a negative slope on the derivative graph. We want the derivative to be decreasing because if the derivative is decreasing, our second derivative is negative. Pointing down. And then a point of inflection happens when we switch from one of these to the other. So when we switch from a positive slope to a negative or a negative to positive. So if you remember before I said like peaks and valleys. So points of inflection on the derivative graph are represented by peaks and valleys. Questions on that part? This little bit here, like if I give you a derivative graph and ask you what the concavity, that's the hardest for almost everybody. Because there's three levels at play. Giving you f prime, I'm really asking you about f double prime of f. So they're kind of doing like all three of them. Alright, f double prime. If f of x is increasing, I don't know anything about f double prime. So don't worry about that. Because we could be increasing and concave down or increasing and concave up. So just increasing is not enough to tell me anything. Relative max. If f of x has a relative max, you gotta have like the top of a hill, right? What's true about the concavity of that relative max? It's gotta be concave down, so what's true about the second derivative? Negative. So the second derivative would be negative. Or below the axis. opposite for relative min, right? If I have a relative min, well then I've got the bottom of a U shape, and that U shape tells me concave up. So the second derivative will be positive or above the axis. These are really similar because it's kind of the same thing. So if the original is concave up, what do we know about the second derivative? Positive. So it's the same thing I just wrote down here. You will use this like extremely rarely. I wouldn't spend a ton of time focusing on that. I kind of regret putting it out there. Concave down, second derivative is negative. Below the axis. And so if concave up is above the axis and concave down is below the axis, how do I find the point of inflection? Across the axis. And in this case, we don't care. The other one we cared because it was like, is it a max or a min? And this time, if it crosses, it's point of inflection. There's no like max or min for that. So it just crosses the axis. Either direction. So I would also get out. I gave you this sheet yesterday. And this is all the same information. It's just some people prefer like a text form. Some people prefer like a graphical form. And I'm going to give you a packet that has some questions on this stuff. And we're going to see how it comes. Yeah.
Do you have an extra sheet?
Yeah. Good. Like, you think it's helpful or you just think it's like an organization?
It's very helpful.
It's like fun to organize. There are some problems on here that are algebraic. You will be responsible for those eventually, like on your test. But today I would want to do the ones that are graphical first, because that's what we're like practicing right now. I'll go over every sheet.
It's too over.
Ready? So don't do the algebra ones.
Like, you're going to have to know how to do the algebra ones. You will want to at some point. But today, I would focus most, but we're going to do some more of that in like 5, 9. So I wouldn't worry about the algebra ones today.
So this is kind of like a 540 packet. It's
This is like a,
specific packet.
this is like a 5, 7, and 5, 8. So I would focus on all the ones that are graphs. And I have the answers like, they're not in Schoology yet, but they will be in like